Now the topic that we are going to discuss is sets. Sets is actually a collection of well-defined and unique objects. So normally we represent the elements of a set by capital English alphabets like A, B, C, etc. And the elements of this set are represented within these curly brackets. Whatever is there within this curly bracket, that means these are the constituents of a set. Every constituent of a set is known as an element, and it is separated by a comma. Like for example, if I say a set A is a collection or a set of multiples of 5, positive multiples of 5, less than or equal to 10. So that would be containing 5 and 10. These two numbers are 5 and 10 are the numbers which are the multiples of 5 that fulfill our condition, and these should be separated by commas. So A is a set that contains elements which are positive multiples of 5 less than or equal to 10. So we should be having these two numbers 5 and 10 only. So that's why these are known as the elements of a set. Okay. Now, if for example, I say that 5 that belongs to set A, so that would represent 5 belongs to set A. And if I say, what about 15? Is that 15 contained in this set? So yes, since that is not contained in it, so we would write 15 is not an element of the set A. Similarly, if a set B, for example, has got any other element, let it be, for example, containing the vowels like A, E, I, O, and U. So it has got 5 elements. We write that as n of B. Number of elements of the set is 5. Number of the elements of the set B is 5. So we can say that U belongs to set B. Similarly, A belongs to set B, but L from English alphabet, that does not belong to set B. So these were some of the examples. Okay. Now let us define an empty set. Let's take another example. C. It is a set, for example, which doesn't contain any element. So it is written either with empty curly brackets or it is written as like this. This symbol is known as phi. Normally, there is a confusion. Some students like might write C equals to like this. So that does not represent an empty set because these elements, these brackets are showing that it is a set and it contains an empty set. So C is not an empty set in this case. So this is not the way to write down an empty set. The right way is either to just draw these empty brackets or to use phi. Okay. When we define some of the elements of a set, we say Like for example, as was the case with set A previously, we had only considered two elements of the set A, which were 5 and 10. Now this set has got two elements. There is no more element of this set A. So we say this is a finite set. That means you can see the last element contained in this set. So that's why it is called a finite set. But if, for example, we define A or a set B as just multiples of 5 or even just the positive multiples of 5, so that B would be 5, 10, 15, and it would be continuing so far. Since our counting does not come to an end, it is infinite. So this set B would also be an infinite set because its last element is not included in this set. So this is the difference between a finite and an infinite set. Okay, then we proceed to exercise 9.10. List all the elements of each set, days of the week. So we just need to enlist the elements in part A. So that would be consisting of obviously the days from Monday till Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. That would be,
Excuse me, sir.
yes,
Sir, can you explain that bracket thing again a little bit?
yes, okay. Bracket actually is the representation of the set, that whatever is there contained within this bracket, that is a part of that set, and all of those things which are there within this bracket are called the elements of the set. A set consists of all those elements which are contained within these brackets. So these curly brackets are actually the symbols of the set. Whatever the set we are considering, these curly brackets represent that whatever is contained in these curly brackets, these constitute that particular set. Similarly, let me just give you an example. As we are discussing with this one, part A, its answer would be days of the week. So we know that days of the week are Monday. So we need to write them completely. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and then Sunday. So when we close these brackets, these represent a particular set. So all the constituents of this set are represented by the elements of this set separated by commas. So in this case, this set has obviously got one element Monday, another the day of the week, the next one that is Tuesday, then Wednesday, Thursday, Friday, Saturday, and Sunday. So we can say that the number of elements contained in this set is 7, since the we know that days of the week are 7. So that's why the number of the elements of this set would be 7. And these brackets just represent the set itself. Okay. Then part B is months of the year. So months of the year starting from January, then February, March, April, and I'm not just writing them down completely, but just explaining them. So second last would be November, and then it would be December. So this is how we write down this set, and these brackets again represent this set that contains the months of a year. Then part C, factors of 36. So we need to include all those numbers which constitute factors of 36. We know that 36 is divisible by 1 because 1 is the factor of every number. Since 36 is an even number, so it is divisible by 2. It is also divisible by 3, 4, 6, 9, 12 3s are 36, then 18 2s are 36, and then 36 ones are. So all these represent this set. This set contains the factors of 36. So we have enlisted the elements like this. So these brackets represent that set, and whatever is contained within these brackets, those are the elements of this set. Okay, then part D. Since we know that colors of the rainbow are red, orange, yellow, green, blue, indigo, and violet. So these would be the constituent elements of this set. Let me draw it precisely. I haven't written completely red, orange, and like that. We just need to write down the colors of the rainbow to represent the elements of this set. Then part E, multiples of 7 which are less than 50. So we know that 7 ones are 7, then 2s are 14, 21, 28, 35, 42, and then 7 sevens are is 49. Since we need to fulfill this condition, that we need to choose only those multiples of 7 which are lesser than 50. So our last element is going to be 49. For part F now, primes less than 30. We know that prime numbers start from 2, and 2 being the only even prime number. The rest of all the prime numbers known are odd numbers. So 2, 3, 5, 7, 9 is not a prime number, it is a composite number. Then 11, 13, 17, 19, 23, and 29. We have enlisted all those elements as was required in the question. We need to list all the elements of each set. Okay, then part G. Ways of arranging the letters in the word toy. Okay. We need to list the ways. In how many ways can we arrange the letters of this word toy? Okay. Let me fix T first. Then I can have the arrangement of either O at the second place and Y at the third place, or Y at the second place and O at the third place. So these are the two arrangements, being T at the first place. Then in the same way, I can have Y fixed at the first place. Then I can have either the arrangement of T and O like this or like this. And finally, I can fix O first, and then I can have the arrangement of T and Y like this, or OYT. So these are the six possibilities that might be there to arrange the letters of the word TOY, making either T at the first place or Y at the first place or O at the first place and shuffling the other two elements. So this is how this question is to be done. Question number 2 now. List two more members of each set. In part A, we have got rabbit, cat, parrot. So more members like this might be a mouse. It may also be like, for example, hamster. There are many more possibilities to be included as the members of this set, but since we were required to include only two, so I have written these two. Okay, in part B, these are vegetables: carrot, potato, cabbage. So we can name any other vegetables like cauliflower. We can write cucumber. We can write down turnip, etc. Okay. Then, in the same way, in part C, we are having these cities: London, Paris, Stockholm. We can also have two more to be like Amsterdam or Dublin. So these may also include into set C. This is the answer to part C. But I do not need to enclose them in these brackets right now, since these two are not the only elements of this set. We have already got these three as well, so we need to write them uh, as a combination of the three previously given in the question as well. So Amsterdam, Dublin, then London, then Paris, then Stockholm. So all together we have got five such elements. Okay. Then for part D, we have got Nile, Amazon, Loire. Uh, these could be Rhine or Yangtze. Similarly, in part E, we have got these different types of trees. So M, pine, oak. We can have coconut trees. We can have mm, pine is already there. We can have deodar trees. We can have tree of any other kind. We can have palm trees, etc. We just need to include some of the trees. Okay. In part F, tennis, cricket, football. These are the name of the games which are played using a ball. So some more games with which are played with balls could be golf. It could also be snooker. It could be rugby, etc. Then in part G, France, Germany, Belgium. Then we can have like Italy or Spain. That may include two more members into this set. Similarly, we have got now mountains, Everest, Denali, Elbrus. We can have K2. We can have uh, Nanga Parbat. We can have any other mountain. We can have mountain of Ohud, etc. So similarly, Beethoven, Mozart, Sibelius, we can include uh, different, like for example, to have two more of its kind, we can have Puccini or Bach, and then in part J, we have got flowers. So we can include the name of any kind of flowers. We can also include rosemary. We can have jasmine. We can have flower of any other kind. Okay, for part K, we have got multiples of 3, 3, 6, 9. So after 9, we can include 12, 15, 18, 21. So any two of these would serve the purpose and so on. Then in the same way, for example, I gave you an example of part N. These are some mood swings, being happy, sad, or angry. We can have being thoughtful. That is also a mood swing, or calm, or aggressive, or uh, joyous. So these may also include. So and similarly for part P, hexagon, heptagon, triangle. These are the closed diagrams. So other than triangle, we can have octagon. We can have pentagon. We can have nanogon, etc. So this is how this question number 2 is to be done.